So, like we said at the very end of the experiment page, the A value, that is going to be your initial value. Your B value, that is your growth or decay factor. If the equation is growth, then the B value is going to be greater than 1. All the examples we had up here was around 1.5. And if it is decay, that B value is going to be less than 1. Pardon?
Will it be above 0?
Yes. Yeah, that's a good question. The B value will always be between 0 and 1 on the decay. So you could put that in there as well. Alright, so we're going to kind of walk through an example how to find these values given a word problem. Okay, so on this one, it says in 95 there were 285 cell phone subscribers in this town. The number of subscribers have increased, so you always need to make sure to be aware of words that are telling you, is it growth or decay? If it's increasing, obviously it's growth. Increased by 75% per year until 2005. How could we find the number of cell phone subscribers in the town in 2004? So, what was the initial number of subscribers in this town? 285. This is usually going to be the easy thing to find, the A value, which is what that number represents. Okay, it's whatever you're starting off at. The B value is a little bit trickier, especially for decay, which we'll get to that in the next example. But on this one it says, for the variable B, we start off with 100% of those initial subscribers, and we're going to increase it by 75%. So the 1, that's represent the 100% of the subscribers initially. But we're going to increase that by 75% as a decimal to get 1.75.
Where's the 1 from? The 100%?
Yes. What I would do, what has helped some people in making that, anytime you see the word that's telling you, hey, this is growth, above it, put 1 plus. And that way you know you're going to do 1 plus whatever the percentage is. Okay. So your equation is going to be the A value, 285, times the B value, 1.75, to the power of x. That equation represents this whole situation. Question C is saying, to find the number of subscribers, we need to determine the number of time intervals. Okay, so it says, that just means, how are they measuring time in this problem, which is years. So how many years would it be from 95 to 2004? 9 years. So I could take my equation, raise it to the power of 9 instead of the power of x. So again, that x, that's going to, 95% of the time, it's going to represent some form of time. The other 5%, it's going to be kind of like what we did today, the trial numbers. Okay, so whenever I do that, how many subscribers were in 2004? 43,871. Okay. Okay, questions on this one?
Why did you put 1 plus 0.75?
100% of the initial plus the 75% increase. Going to the next problem. So on this one it says a new black Mustang costs $40,000. It depreciates. So there's the word that is telling me what kind of problem this is. So above it I'm going to put 1 minus. Usually later in that sentence that tells you growth or decay, it's going to give you that percentage. I've also had some people that go ahead and write that as a decimal. So they've got the simple addition or subtraction that's going to give them the B value. On this problem, what is the initial cost of the car? $40,000. Again, that is the initial value, which is the A. So because this is decay, I'm going to do 1 minus 0.12, which is going to give me 0.88. Now, here in a little bit, we're going to have some problems where you're going to be given an equation and you have to say that it's an increase by this percentage or a decrease by this percentage. If it is a growth, it's easy to tell because, okay, 1 point something, it's growth by whatever number that is, 75%. Decay is a little different. You've got to kind of have this in your mind right here. People struggle telling me that 0.88 is a 12% decrease. It is not an 88% decrease. Okay, so you've got to really be careful, especially on the decay. So your equation is 40,000 times 0.88 to the power of x. For question C, I'm just going to put 5 in there. And then whenever I do that, that will tell me how much that car is worth. Which, Dylan, what would that be?
21,109.
Okay. And then on the last one, it says, how long will it take for the value of the Mustang to be less than $18,000? How can I solve that? Okay. Both those answers right there. You can guess and check. We know that after 5 years, it's 21,000. Okay, that's getting close to 18,000. So I could plug 6 in there, see what it gives me. Plug 7 in there, see what it gives me. Plug 8 in there, see what it gives me. Probably a more efficient way is to do 40,000 times 0.88 into y equals. And then just go to your table and find the first x value when the y value is less than 18,000, which on this one would be 7 years. Okay. Next unit, and I want you to know this right now, if I ask you to solve for x right now, this is how you're going to do it. Okay. The next unit, we're going to get into logarithmics. Logs is how you solve for exponential. Okay, they're opposites. A lot like square root and to the power of 1/2. A lot like, square root and squaring something. A lot like adding and subtracting are opposite. Multiplying and dividing are opposites. But since we haven't gotten there, this is kind of how we'll solve these in this unit. Is really using the calculator on those. So these are the problems I was talking about. You need to be able to look at an equation and tell me if it's growth or decay, and also by what percentage. Okay, so looking at number 1, Tate, would that be growth or decay? Growth. By what percentage? 20%. 20%. Do what? You say y20? Because 1 plus 0.2 would give me 1.2. 20%. Allie, number 2, would that be growth or decay?
Decay.
By what percentage?
44.
By 44%. Peyton Edwards, number 3, would that be growth or decay? By what percentage? So if it's 5, 50. Be careful with that. It's a common mistake a lot of people will make. Mark, number 4, growth or decay.
I put growth by 70.
Growth by 70%. Alright. And a way that you can look at whenever you're finding the percentage, you're always finding the difference between the b value and 1. Okay? If it's growth, it's always going to be the b value minus 1. If it's decay, it's 1 minus the b value. Peyton, number 5, is that growth or decay? Wiseman.
Growth.
By what percentage?
300.
300%. And Liam, number 6,
It's growth.
by what percentage?
2%.
2%.
Wait, how's number 244?
How's number 2 44? Because I need to find the difference. So 1 minus my b value is going to give me 0.44, which as a percentage is 44%.
Okay.
Alright. I do want to talk about one quick thing over here. Actually, never mind. We talked about it on the graph right here. So we're just going to do 2 quick graphs, and this will really be it. Or it will be it for today. But you got to be careful because looking at this first equation, what is the a value? If it's 2, then what's the b value?
1.
Okay.
1.
So the a value is 1, the b value is 2. And let's talk about this real quick. So if you have this, do your best whenever you're identifying the a and b. Don't necessarily read it left to right and think, okay, the first number I come to is the a value. The b value is always what is being raised to the power of x. So if there's only one number in the equation, your a value is 1. Okay, so I can go through here. You can put this into y equals and get these values, but it's not that difficult. Anything to the power of 0 is 1, which there's my a value. And we'll connect that to the graph here in just a second. 2 to the power of 1 is 2. 2 squared. 2 cubed. And then whenever all those exponents are now negative, that's just going to end up giving you a fraction. The a value on your table is always going to be that y-intercept. Okay, that's where you're going to find the a value from the table. So I can graph these points. And if you're looking at the graph, again, 0, 1, that's your y, or that's your a value, I'm sorry. The y-intercept is your a value. So if you're looking at a domain, whether it's growth or decay, that's what you're looking at, negative to positive infinity. Now on the range, if you look at the graph, if you kind of follow the red line up here, it goes down and it starts to flatten. And it's going to look like it stays flat forever right there. That means that it is getting closer and closer to a what?
0.
Okay, it's getting closer and closer to 0. And it never touches it. But what is that line called that it never actually touches? Asymptote. Okay, so we're going to have horizontal asymptotes on this. And if it never touches it, then I need parentheses. And your asymptote will always be somewhere in your range. Okay. Next, let's go through this one down here. So I've got 4, 2, 1/2, 1/4, 8, 16. Go ahead and just give you those values. So again, there's 0, 4 on the table. That's my a value. And that is my y-intercept. And I may have messed up. I messed up those values. Those last two values, that should be 1 and then 1/2. Sorry. And on this one, because the asymptote is still at 0, your domain and range are going to be the same. That asymptote is going to move around next class whenever we're going to talk about transformations. The last thing I want you to write, and you're going to just write it in between the two graphs, to find the b value. You're going to divide any y value by the previous y value. Let me just kind of quickly show you how that works. So looking up at the first one, 8 divided by 4 is what? 2. 4 divided by 2 is what? 2. 2 divided by 1 is 2. 2 is my b value. Okay? 8 divided by 16 is 1/2. 4 by 8 is 1/2. 2 by 4 is 1/2. On that one, my b value is 1/2. So if you have the table, as long as you have the y-intercept on that table, you can write the equation. Okay?